Let's talk about GitHub Copilot. Is it really this super revolutionary tool that makes your work as a software engineer or cloud DevOps engineer and so on way easier, way faster, or in some cases even replace the need for engineers? Is it really as good? And what are some of the common use cases of using GitHub Copilot? And in this case, we're going to be specifically focused on the work of cloud and DevOps engineers and even compare that to GitHub Copilot's value and usage for software development. So let's get started. First of all, what is GitHub Copilot? Well, in very simple words, it's an AI assistant for coding. That means GitHub Copilot is used in a code editor or in an integrated development environment like Visual Studio Code, IntelliJ. So any kind of IDEs where you integrate GitHub Copilot and it helps you write the code within the editor. So compared to ChatGPT, for example, we have ChatGPT in a browser, so you have to switch from your code editor to the browser to type in your request, and it gives you some code with explanations. In this case, you have that AI tool integrated within the editor, so you don't have to leave your editor to get the replies and get the code suggestions and so on. And the way GitHub Copilot works is that it has way more context than ChatGPT, for example. That means that it actually takes your code, your existing code, whatever you have written and whatever you're writing as a context to answer your questions. And also very important to know that the context that gets uploaded and sent to GitHub Copilot is not your entire workspace, because you may have hundreds of code files that may not be relevant for whatever you're asking. So usually whatever you have open in your editor currently, so you may have 5, 10, 20 files that you're working on currently in the editor, plus you have the file that is currently open where you're working inside. So it takes all of that as a context, assuming these files and the code inside are relevant for your current question, because that's exactly what you're working on right now. And this added context is actually a huge advantage because you don't need to provide the entire context to Copilot. You can just say, give me whatever for this highlighted code, or give me whatever for my entire workspace or code base. So how does GitHub Copilot work behind the scenes? GitHub Copilot actually uses an OpenAI large language model behind the scenes, and it's been trained with billions of lines of code and text, like code explanations, that are publicly available. So based on that large amount of data, it can give you suggestions based on the best practices and so on. In addition to just replying to your request, when you explicitly ask something from GitHub Copilot, it actually gives you code suggestions itself. So when you start typing out your code, it actually gives you kind of auto-complete suggestions by trying to predict what you're gonna write. And again, as I said, because it has all the context, if you already have a project that you're working on, so you're not just starting from the blank page and the first file, it actually takes whatever you have open as a context, and based on that, it will try to guess, okay, this is what you're trying to do next. And it will give you code suggestions based on that. It will even give you comment suggestions with the entire block of code. For example, if you're creating EC2 instances and you have that configuration inside, it may suggest you to create security group with firewall configuration for those EC2 instances, for example, if it detects that you don't have security group configuration yet. So it tries to guess and give you suggestions what you should write in the code. Now, and this is a very important part, there is one small problem with GitHub Copilot, which we're going to see later, and that is that it's not up to date. For coding or programming specifically, GitHub Copilot actually is way more helpful than for writing infrastructure as code. However, as I said, there are still some use cases and some advantages of using GitHub Copilot, even for infrastructure as code scenarios, and we're going to see both sides in the demo. So we're going to see the usage, how it helps and how it may help in writing code, but also limitations of GitHub Copilot. So we're going to see kind of both sides in the demo. So let's go directly to the demo and let's see how it all works. And in the demo, we're going to be using GitHub Copilot, obviously, with Visual Studio Code. And for the infrastructure as code tool, we're going to be using Pulumi with the Python language. Now, if you're new to Pulumi or Python, I actually have very detailed tutorials on both of them separately, so you can watch them first and then come back to this one. So as a first step, of course, let's get our prerequisites right, and let's do all the setup that we need in order to have everything installed, everything up and running, and ready for our demo projects. And this is everything that we need for our demos. First of all, we need our AWS account. I'm logged in as an admin user, and I'm going to be creating infrastructure in this specific region. You can choose whatever region you want. So we need AWS Cloud Platform because we're going to be creating infrastructure here with our infrastructure as code project. We also need Pulumi installed locally because we're going to be executing a Pulumi project with Pulumi commands, and you can very easily install or download it by following their installation guide for whatever operating system you have. I have macOS, and I'm actually going to use the package manager to install it. You can also download a binary and just install it with a graphical user interface. So whatever operating system you have, whatever installation option you want, you can use it to have Pulumi installed locally. So I don't have Pulumi yet, so I'm going to install it using Brew Package Manager. And installation was successful. Let's validate it by executing a Pulumi command. So let's do Pulumi version. And this is the version that I have just installed. As I mentioned, with Pulumi, you can actually choose whatever programming language you want to work with. And in our case, we're going to go with Python. And again, if you're new to either Pulumi or Python, I have separate extensive videos on both topics. So you can go ahead and watch those separately if you want to learn them properly first. So since we're going to be using Python for Pulumi, we also need to have Python installed locally and actually have Python version 3 already available. If you don't have it, again, just a simple install Python 3 search will give you the download guide on the official documentation for whatever operating system you have, so you can download it as a binary and just install it easily like this. We're also going to need Visual Studio Code. That's where we're going to be writing our code, and this is where we're going to integrate GitHub Copilot to actually help us in writing the code in our editor. Just search for it. Here's the download guide, and again, choose a download for your operating system and install it locally. And the final thing that we're going to need is, of course, the GitHub Copilot itself. So the way we're going to get this is, first, we're going to need a GitHub account. So if you don't have one, just sign up in GitHub. It's free, it's easy. So just register. And I'm actually going to look for GitHub Copilot here. So we're going to get to the link directly. There you go. And if I click on Get Started with Copilot, you see different payment options. So of course, as an individual engineer, you don't need a business or enterprise license. So we can go for the individual one. And this one actually has a 30-day free trial, which is great because it gives you enough time to actually play around with the tool and decide if it's actually worth the investment, if it really makes you productive in your work or not. So that means you can follow this tutorial along completely free using a free trial. So I'm going to choose this one as well. And now we're going to sign in to our GitHub account. I'm going to authenticate, and there you go. And here's an interesting note that GitHub Copilot is actually completely free. So you don't need to even pay the individual license. If you are an open source maintainer, teacher, a student, which they check on a monthly basis. So if you are one of those, you can actually use GitHub Pilot for free. So I'm going to click on Get Access to GitHub Pilot. And we're going to select a couple of options here regarding the policies. So the first configuration option lets you control whether GitHub Copilot can generate code suggestions that match code found in public repositories on GitHub. So private repositories on GitHub or any other repositories outside of GitHub will not be considered here. And if you allow this, when Copilot gives that code snippet that matches some code on the public repository on GitHub, it will also provide you with details about the matching code, like any license identified for the repository, as well as the source for the code, and so on. In our case, actually, let's allow this one. And the second option allows you to decide whether the prompts that you give GitHub Copilot to generate code for you, plus the context that GitHub Copilot takes to reply to your questions, whether you want all of that to be collected and retained by GitHub and processed further, as well as shared with Microsoft. Because as I mentioned, the context is basically what gets sent up to GitHub servers so that Copilot can use that rich context to give you a better, more precise replies. And with this option, you can decide whether GitHub can retain that context that was uploaded and process it to improve the Copilot even more. Now, this can be an important security consideration, especially if you're developing an application which is private for your organization, or maybe you have developers that are hard coding some secret information or sensitive information in the code, or you are basically testing out and adding the API keys or whatever sensitive information directly into the code, maybe for local testing, not even for pushing it to the remote repository. So that may be sent as part of the code snippets. So based on that, you can decide whether you want to reject and make sure GitHub doesn't keep any of this data and doesn't process it, or you can decide to allow it. In my case, I'm going to allow it because this is just a test project and all of the code inside can be sent and retained by GitHub. Save and complete setup. And we have this confetti flowing down because we have successfully activated GitHub Copilot. However, we need to use GitHub Copilot in our code editor because the Copilot is going to help us write code, right? So we need it directly integrated in our IDE, in this case, Visual Studio Code, and we have these options that we can choose from. So I'm going to choose this one, and it jumps into the step-by-step guide of how to integrate it in Visual Studio Code. So all we need from this documentation is this section here. So we have all the prerequisites, everything is activated and in place. So right now, all it's left to do is to go to Visual Studio Code, find the GitHub Copilot extension, install it, and we're going to be good to go. So basically, these 6 steps is all we need to activate GitHub Copilot in Visual Studio Code. So I'm going to go to the extensions and look for GitHub Copilot. And there you go. This is the official one from GitHub itself. So let's install it. We need to sign in to GitHub Copilot, as is also mentioned in the documentation. So let's do that. We're going to authorize Visual Studio Code to access our Copilot, and that's it. Our GitHub Copilot extension is installed. So now when we start writing our infrastructure as code for provisioning AWS infrastructure, we're gonna have Copilot directly integrated into our editor so we can use it for our demos. Awesome, so everything is set up for us to start the demo. So as a first step, let's create a new Pulumi project using Pulumi CLI. So to initialize a new project, in the Copilot Pulumi folder, we're gonna execute Pulumi new, and we're gonna give Pulumi kind of a template of what we are trying to create here. As we learned, Pulumi supports multiple programming languages. In our case, we wanna create a Python project, which is gonna build infrastructure on AWS. So the template name will be AWS Python, and you can actually look up all the Pulumi templates when you're running Pulumi new command right here in the GitHub repository. So the one we are using is AWS Python. So let's go ahead and execute this. And this is actually a very convenient way to provision everything that Pulumi needs for the configuration instead of writing everything from scratch. So the first thing we're going to do is an access token from Pulumi. So of course we need to authenticate that this is our Pulumi account that we're using. And Pulumi also has a really nice UI where you can track all your projects and infrastructure configurations that you create. That looks like this with the dashboard and project and stacks and so on. And in the personal access tokens, we're going to create a new token. And we're going to call this also AWS Python. And we just provide it here. So now we're gonna configure the project details. Let's call the project Copilot Pulumi. Take the default project description, stack name, we can leave it at dev, and AWS region to deploy into. I'm gonna choose EU West 2, which is London region. You can choose whatever is closest to you. And as you see, Pulumi is actually doing all the main configuration behind the scenes, and let's see what we get as a result. Awesome. So the project was initialized, and because this is a Python project, it actually created a Python virtual environment where all our libraries will be downloaded for the Python project. It also created this boilerplate Python code for Pulumi. It gave us the configuration for the dev stack or development environment basically, and some other stuff. Plus, because we specified that we want to provision infrastructure on the AWS cloud platform, it actually automatically included the Pulumi AWS library, which we're going to use to create different resources on AWS, which we're using right here. So all this boilerplate code basically that we need for the project was provisioned automatically, which is pretty convenient. And as I said, the requirements.txt, which is like a dependencies file for a Python project. So all of that was downloaded automatically. Cool. So now we want to finally see GitHub Copilot in action, right? So how do we use GitHub Copilot? Well, first of all, if we create a new file in our project, and let's call it test.python, doesn't matter. You see that immediately the first line is a prompt to ask GitHub Copilot to help you write code. And using this shortcut, which is Command-Shift-I on Mac, or whatever shortcut you get displayed in another operating system, you can use this chat to ask GitHub Copilot for something, or you can use it inline using Command-I, like this. Or if you don't like shortcuts, you can just open GitHub Copilot chat right here. So you always have this on the left side to fix your code issues or explain the code that was written maybe by other developer and so on. So let's actually use GitHub Copilot for some really simple examples. Let's remove this. And this is a boilerplate that Pulumi generated, which is just creating an S3 bucket. So let's ask GitHub Copilot to give us code that generates 10 buckets in a loop, for example. Create 10 S3 buckets with unique names. Let's see what we get. And it actually generated this code in a for loop, which is a Python syntax, to generate those buckets in a loop, and each one will get some unique name. And let's say we want to replace this whole code block with this one. You can just click here, and here we have a new code block. Now, let's say when you're coding and writing your infrastructure configuration file, maybe you don't always want to go to the chat, generate something, copy that code, paste it in. A more convenient way to work in your code editor while you're writing code is actually to use inline GitHub Copilot suggestions, right? And the most convenient option is actually code suggestions. So if I clean all this up, I can write a comment here, just a simple comment that says, create 10 S3 buckets with unique names. And if I hit enter, you see that it auto-suggests the code. And again, which is pretty much same as here or similar. And now let's say we want to keep writing configuration for other components of infrastructure. Let's say create 5 EC2 instances for my web application. And we have the whole suggestion for that configuration. Sometimes you get multiple suggestions. In this case, both of them look pretty similar, just a small difference. And whichever one you like, you click on accept right here, or you can just hit on the tab and it fills in the entire configuration. And let's say right here, we want to use another instance type instead of T2 micro. Use T2 small instance type and gives a new one. Here we have an AMI, which is usually an ID that we need to go to AWS and look it up to define a value here. So here again, let's ask GitHub Copilot to actually use an Ubuntu operating system instead of the Amazon Linux AMI. And we actually have two suggestions. And if I switch to the second one, it says use Ubuntu 18.04. And if I delete that, it will give me a suggestion for the Ubuntu AMI, which would be very convenient because I don't have to look up AMI in the AWS console. So as you see, we can control the flow and what Copilot suggests us using the comments. Let's do one more thing, which is right here, as you see, it uses S3 from Pulumi AWS library, but it didn't import EC2. So let's actually ask this to import S3 and EC2 modules from Pulumi AWS package. And if I delete that, we get both. And of course, you can remove the comments that are kind of cluttering the code and only use them to get suggestions from GitHub Copilot. So as you see with this simple demonstration, the main benefit or the use case of GitHub Copilot, just like any other AI code assistant, is to let you program with a human language, or in this case, English language, and let GitHub Copilot give you the actual code for that logic. Now, this may look really cool, and it is in most cases. However, there is a huge drawback of GitHub Copilot used in practice for writing infrastructure as code projects. And that is that it's outdated. So basically, the latest state of GitHub Copilot code for most of the languages, most of the information that it knows about is from September 2021. And that is a pretty old date considering the speed of technological developments. Every infrastructure as code language or tool develops really fast. So you have new libraries, improvements every couple of months that are being released. So 2021 is actually a very old state. And we can even ask Copilot itself what the last date of its information is. As you see, this is September 2021, and the information since then has obviously changed. And because of that, we're getting this older version of Ubuntu as well as the older AMI image from Amazon, right? So if I check Ubuntu versions, obviously we have new versions here. Ubuntu has released 2 major versions since then, so this AMI will be outdated. And of course, in our infrastructure, we don't want to be provisioning servers with outdated operating system versions and images. That will be a very bad practice. And I also want to mention one very important distinction between using GitHub Copilot for programming as a software developer and using GitHub Copilot for infrastructure provisioning. Because programming languages like Python, Java, JavaScript, whatever, these programming languages are way more established, and the functions and libraries and so on, they don't change as much and as frequently compared to a relatively new infrastructure as code tools. Like Pulumi, Terraform, obviously improvements are made way faster, and a lot more is going on in that area. And because of that, it's way more challenging to use GitHub Copilot for infrastructure as code projects because the chances of functions or attributes or libraries being outdated is way higher here. So that is a very important distinction when analyzing GitHub Copilot's value in each category. And that means if you are a DevOps engineer or cloud engineer that is automating stuff, you want to use GitHub Copilot, it definitely helps with speeding up the code. However, overall, you will probably have to double check and reference the up-to-date documentation for each configuration option. So that is a huge disadvantage of GitHub Copilot right now, which is that it's outdated. So now, considering this limitation of GitHub Copilot, let's still see in what other use cases we can use GitHub Copilot to actually get some value out of it. So I'm gonna clean this up and let's do one more thing here. So what I'm gonna do is I'm gonna create a temporary file here, which is going to include Terraform code, which creates a VPC and EKS cluster. And let's say in our scenario, we want to migrate a project from Terraform to Pulumi. We already have a project that provisions, configures infrastructure that is written in Terraform, but we want to migrate it to Pulumi. So we can ask GitHub Copilot to actually help us do the translation from Terraform to Pulumi code. So this is a simple script that basically creates a VPC for the cluster by defining the private subnet, public subnets, and so on. And then it creates an EKS module in that VPC with some simple configuration, such as one node group with this instance type and so on. So let's ask our GitHub Copilot, first of all, to explain whatever is written right here. So let's say we don't know Terraform as well. We are trying to migrate a project that somebody else wrote in the team to Pulumi. So we want to ask GitHub Copilot to explain that code first so we know exactly what it's doing. And GitHub Copilot, we can use dash and one of the commands basically that references the workspace. That means it takes our entire workspace as a context for giving us the answer. So we're going to ask it to explain the highlighted Terraform code in detail. And it gave us a breakdown of what we're provisioning. We need to set this variable value somewhere. They were retrieving the AZs from the current region. That in the EKS configuration, we're enabling public access to the cluster, which is right here, as well as disabling of cluster and node security groups. So it will be using the default ones. And again, you can ask it to go into details and explain each and every attribute so you can understand the code, which I believe is one of the really good use cases of Copilot, because very often you're going to be working with code that looks very complex, that has become complex over time, but because you are seeing it for the first time and you didn't write it yourself, it may be a huge help if you let GitHub Copilot basically analyze the whole thing and tell you what's happening there. So now we're going to ask Copilot to translate this entire Terraform code into Pulumi Python code with the exact same configuration for creating VPC and EKS cluster. And let's see what we get. And another very important note is that if you are following this demo and you ask Copilot the same thing, you will most probably get something completely different. You will even get different answers every time you ask the same question. So it basically comes up with a new answer on each question. It means you can't expect that kind of consistency, which has both advantages and disadvantages, obviously. But let's see our Pulumi code, and then we also have some explanation here that says it does the same thing as Terraform code we provided. We have the same instance type, the capacities of the node. Somehow it took the Kubernetes version 1.21 because that's the last version that Copilot actually knows of. It doesn't know that Kubernetes cluster version is, I believe at this point, it's 1.29 already. So now we can actually move this code into the Python file. And also notice the follow-up question that it suggests itself. So we notice that we're not creating security groups for VPC and EKS cluster, and it suggests us to add that configuration. So if I click on this, it will actually give us the configuration for that as well. That we can add additionally in our configuration. So let's see what it gave us. It's creating a new security group in the VPC, which is always a good practice to create new components, because when you tear down your infrastructure using your infrastructure as code project, you can cleanly delete everything, basically. And then it adds a rule to the security group. It basically opens up incoming port 80, and it references that security group in the cluster. And it gives us another follow-up, which is for configuring load balancers in the EKS cluster. So basically, it will give you more and more suggestions to try to be helpful. But as I said, you have to be aware that every configuration that you get here, generated by Copilot, you will have to validate. Because, as I said, the huge drawback is that it's outdated, and we obviously don't want to use outdated configuration. Plus, when we execute it, it may not actually work because some attributes, some libraries will be outdated, etc. And one obvious one is the Kubernetes version that it's using right here. Kubernetes 1.21 is probably not even supported on EKS anymore. So very important to be aware of this. And that also means that if you are a non-experienced engineer, cloud or DevOps engineer, Copilot may help you in explaining some stuff and giving you a boilerplate, but you will have to still do the work of understanding what the configuration does and actually going and validating against the official documentation to make sure that it's working. Another example is that GitHub Copilot is actually using the EKS module from the Pulumi AWS package. However, Pulumi has actually a new package called Pulumi EKS, which is actually a preferred and also easier way of provisioning a cluster. So GitHub Copilot is not using this one. So again, as I said, you need to be aware and you need to actually know the tool itself, because GitHub Copilot is not a replacement of your knowledge. It's literally just to help you speed up your working process while you have all the knowledge. And that's why it's also called Copilot and not a pilot, because you still are the pilot and you have to have the knowledge and know exactly what you are trying to achieve and use GitHub Copilot in very specific areas. So it's not gonna replace a lot of your work. It may just speed up some of the processes. And I can also demonstrate that actually if we execute this code without making any changes, and we're gonna execute Pulumi up. So as I explained in my separate Pulumi tutorial, Pulumi actually uses the AWS credential configured by default. So either if you do AWS configure command or if you export the AWS environment variable for access key and secret key, I already have my AWS credentials configured here. So that's what Pulumi will actually use when I execute Pulumi up. So let's see if this configuration is even working and if it will succeed to provision the cluster with this configuration. So we got our first error. Now for working with Pulumi specifically, there is actually another AI tool that will be more helpful in this case than Copilot, which is Pulumi AI itself. So Pulumi has this AI tool that you can use basically for the same purpose of asking it questions to give you a configuration, a Pulumi configuration for a specific infrastructure provisioning need, which is also very convenient because you don't have to dig in the official documentation to put together a more complex configuration. And Pulumi UI actually has a more up-to-date state of information than GitHub Copilot. I believe the latest state of Pulumi AI is the information from end of 2023. So it's definitely more up-to-date. So let's actually ask Pulumi AI to create EKS cluster with, let's do 2 node groups. One node group with 3 T2 micro type, second node group with T2 small type, let's say instances. And let's see what we get here. And this actually looks better because, as I mentioned, Pulumi EKS is a new or relatively new library that has better cluster defaults when creating an EKS cluster. And we got our desired configuration code for Python language specifically with additional explanations. So here we have 3 nodes of T2 micro. It also just automatically set the minimum and maximum size of the instance within the node group for auto scaling, basically. And here it gave us 2 T2 small instances. So as I said, Pulumi AI is actually very good if you're working with Pulumi specifically to give you proper configuration very fast, which is more up to date than Copilot. And here we got an error that var is not defined, which is true because this was actually a leftover from Terraform. So let's actually ask Copilot to give us proper tags like this one. Let's remove this. So we can control this either with comment, or we can just start typing and it tries to fill in the information. So I'm going to remove this, and there you go. Also, you see that we have a couple of other issues here, that it's just creating one subnet instead of multiple ones. So again, comparing these two configurations, you see that this is actually pretty up to date, and I would probably have to rewrite the entire configuration to get it to work, one, and also to be more up to date, like using the more up to date library that configures all the defaults in the background automatically for me instead of using this configuration. Especially if I'm writing an infrastructure from scratch, I would either reference an official documentation or, for Pulumi specifically, get some help from Pulumi AI as well. And there is one last thing that I want to show you that you can do with GitHub Copilot and Visual Studio Code, which is another type of use case for AI code assistance, which is a voice assistant. We can speak our command into the editor, and Copilot will give us reply based on that. And this probably is not the most common use case, but I think it's a really cool one. I can't imagine that you would use this at work if you're sitting with a bunch of other people, just talking to your laptop and giving it commands. So maybe a use case for a home office. However, if you have a very complex scenario or logic that you want to describe to your GitHub Copilot, and you don't want to type it out, and you kind of want to explain it in a speech, then this could be a really cool feature. So let's try this out. And I want to mention here that GitHub actually did create an extension for Copilot using a voice command, but they discontinued it recently. So GitHub itself doesn't have that functionality. However, we can use an extension called Visual Studio Code Speech. This is the one from Microsoft. So this was installed. And now if I go back to the chat, you will see this audio icon appeared, or a microphone icon appeared inside the Copilot chat. So now I can use this to actually dictate my command to Copilot. So let's try this out for our last demo. And I'm going to ask it to create an EKS cluster again with 3 node groups. And I'm going to explain the configuration for each node group, and let's see what we get. Create an EKS cluster with 3 node groups. The first node group should have 2 desired instances with T2 micro type, and the second node group should have 3 instances with T small instance type. The third node group should have 4 desired instances with T2 medium instance type. So let's see what we got. We got our cluster, again with an older version, and we got 3 node group configurations with the desired attributes that I asked for. And now I'm going to ask it the suggestion that I get here, which is configure autoscaling for all 3 EKS node groups. And again, as I said, the limitation of Copilot of not having up-to-date code documentation is a big minus here. However, if you are an already experienced engineer, there are definitely some use cases where you can use GitHub Copilot to help you in writing your infrastructure code. And finally, to make sure that we at least have some configuration that's working, I'm going to use the code from Pulumi AI. And as you see, we don't have to create VPC or subnets here because this new Pulumi EKS library actually has the default configurations for the EKS that it creates automatically in the background. So we could create a cluster without our own VPC configuration, just to get a cluster up and running faster. And let's save this, and I will execute the code with Pulumi app. And obviously we get an error because Pulumi EKS was not installed. And there is also this feature in GitHub Copilot that tells you or explains to you the output in the terminal. So if I click on this, it actually will tell me why this error happened. And here is giving me an output to install Pulumi EKS. And this is not using the PEEP3, the latest version. Again, a bit outdated. So to install Pulumi EKS library in our virtual environment, of course, we're going to activate the virtual environment first. And here we're going to use PEEP3 and not PEEP to install Pulumi EKS library. Let's do that. And run Pulumi up again. So after executing Pulumi up command, you see that our stack was created, and then all the resources inside the stack, like cluster, resources behind the scenes like the cluster and node groups. And as I said, this Pulumi EKS actually in the background creates all the necessary roles and permissions for the cluster, as well as security groups and VPC, etc. So we don't need to specify those. Here are our node groups, both of them with T2 micro and T2 small. And Pulumi doesn't execute or provision everything automatically. Instead, it gives us a preview of what will get created, which resources. So you see this breakdown of infrastructure resources that will be created, even though we have just defined the high-level components. So that's a good overview to have of what's going to happen on our AWS platform. And also, in case the configuration is wrong or some attributes are not defined properly, of course, it's going to give you an error instead of this successful preview. So in our case, we can either confirm and we can say, yes, please go ahead and create all this stuff listed in the preview. Or we can say, no, we just wanted to see the preview, so we don't want to actually provision anything on the infrastructure. So I'm going to cancel it because we just confirmed that our configuration worked. And this was our GitHub Copilot demo with Pulumi. I can understand that it can be a little bit disappointing when you're expecting this super powerful, awesome AI assistant that's going to change your life as an engineer, which in our case, as you saw, is not the case. Again, specifically for tools that are being developed and improved very quickly. So a state 2 or 3 years ago is already going to be super out of date. But I hope that I was still able to give you some insight of the usability and value of GitHub Copilots, as well as kind of compare it to usage in different engineering roles and kind of give you an overview of its features that GitHub Copilot offers that you can use in your editor. Please let me know if you have worked with GitHub Copilot or any other AI assistant tool. What is your experience with it? And have you been able to extract a real value out of using it? Or generally, which AI tools are you using in your projects? Please share it in the comments for me, but also for other viewers, because I'm sure that a lot of people will be interested to see various use cases from other engineers as well. And with that, thank you for watching and see you in the next video.